Yeah, we can start. I welcome all the participants for this AROHAN lecture series 15. Today we have a session from Dr. Karath S., Assistant Professor, Department of Electronics and Communication Engineering, Government Engineering College, Chamarajanagar, and he is delivering a talk on image processing using a GEN model. Just to introduce him, Sharath currently working as Assistant Professor in Electronics and Communication Engineering Department at Government Engineering College, Chamarajanagar, and he has received his BE in Electronics and Communication Engineering from APS College of Engineering, Bangalore, and MTech degree from the degree in VLSI Design and Embedded Systems from REC, Bangalore. And he has more than 14 years of experience in teaching and industry, and his major area of interest include VLSI design, image processing, and communication. So on behalf of all the participants and officials of DTE, I welcome you, Sharath.
Thank you, sir.
Yeah, now I request you to please carry on, take your session. Thank you.
Thank you, sir. Thank you. I would like to thank Dr. P.C. Basuraju, sir, for giving me an opportunity. Thank you, sir. Okay. Good evening, everyone. I welcome everyone to my talk on image processing using GAN model. So the contents are introduction to biometrics. So basically, I'll be talking about biometrics. What is biometrics? What are the different types of biometrics? What are the advantages? So I'll be talking on those things. Then moving on further, I'll be talking about GAN basics. What is GAN? What it is made up of? What are the components of the GAN? How to train your generator? How to train your discriminator? Then using the GAN model, I've implemented a paper based on the human recognition model. I'll be talking about that. Finally, the conclusion. Introduction. In the modern network society, the people can access their information anytime, anywhere, but there are some risk factors where there can be unauthorized access. So the basic types of authentication methods are using your password PIN, using your ID smart card token, and nowadays you are using biometrics. So the traditional methods are password PIN, ID card, smart card, token. So the problem with PIN and ID cards are the passwords can be lost, it can be forgotten. The worst is it can be stolen or it can be used by a thief or an intruder to access your data, bank accounts, car, etc. So to overcome this problem with the traditional authentication method, we can solve the problem using biometric technology. So what is biometric? The biometrics is derived from the Greek word. Bio means life and metric is to measure. Biometrics are basically used for measuring and analyzing a person's physiological or behavioral characteristics. The biometric characteristics are unique to the individual, hence are used to verify or identify a person. There are two biometrics are basically divided into two types. One is the physiological, the second is the behavioral. Physiological characteristics are body parts. It can be your fingerprints, hand geometry, facial recognition, iris recognition, retina recognition, DNA, vein pattern, skin spectroscopy. The other component is behavioral characteristics, that is based on the action of the body. It can be through your voice recognition. It can be the way in which you type, that is your dynamic signature analysis, or keystroke analysis. The way in which you walk, it is your gait pattern analysis. So the characteristics of your biometrics is universality. It is the presence of all traits in all the persons. Basically, the biometric is present in each and every person. Distinctiveness, the biometric is unique to a given individual. Permanence, the biometric remains constant and unchanging throughout your lifetime. Second is your the collectability. It can be easily acquirable and measurable using your simple biometric components. Performance, adequate accuracy, speed, robustness, and lesser resource requirement. The authentication can be done at a faster pace. Acceptability, cooperation by the public in giving the samples. And finally, circumvention, which is a foolproof system. What are the benefits of the biometrics? Basically, it overcomes drawbacks of your traditional systems. One is a password-less approach to identifying the individuals. Your biometrics are hard to fake or steal. The feature of your biometrics remains same throughout your human lifetime. Then by using your biometrics, individual can be recognized in less time. The biometrics are non-transferable and efficient because the templates of your biometrics that we store use less memory. Applications. Biometrics are used in day-to-day applications. Knowingly and unknowingly or unknowingly, we are using the biometrics every day. It is used in commercial applications, computer network login, electronic data security, e-commerce, internet access, ATMs, physical access control, distance learning, etc. It is used in government applications like Aadhaar identity card, driving license, social security, border control, passport control, etc. It can be used in forensic applications for dead body identification, criminal investigation, then parenthood determination. Biometric time clocks. Nowadays, all the attendance-based systems are based on biometric. Biometric time and attendance systems where an individual from an organization can be used to monitor. Biometric access control provides strong security at the entrance of the organization. It can be used to authenticate a given individual. Biometric airport security deployed at the airports to authenticate passengers and employees. And biometrics are used in cloud computing also. Face recognition challenges. Face recognition is a challenging, fast-growing, and active research area which has received significant attention because of its numerous applications in access control, law enforcement, security, surveillance, internet communication, and computer entertainment, etc. The present face recognition systems yield satisfactory performance only when you have the images under controlled scenarios. In the uncontrolled scenarios, it is very difficult to identify or authenticate a given individual. So the real world scenarios are basically unconstrained conditions such as illumination. There might be illumination changes. The individual might have, or the image is taken in with different poses, the pose variations. And there might be background variations, and there might be blockages, which we call as acculations, and the expressions of the individuals might also vary. So the real-time scenario is very difficult, and it is very difficult to identify a person in unconstrained conditions or real-world scenarios. GAN basics. So what is GAN? GAN is generative adversarial network. It is generative adversarial networks. GAN are basically the generative models. This was first initially developed by Ian Goodfellow and his colleagues in June 2014. Your GANs are typically deep learning model composed of two components. One is the generator, which we call it as a generative network, and the discriminator, which is a discriminative network. What is the basic function of your generator is it is to generate the fake data. So it generates the fake data in such a way that it looks like a real data. What is the function of your discriminator is, as the name itself tells, it has to identify the real data, and it should discriminate the fake data or discard the fake data. So the generator and the discriminator are two neural networks, or the basic architecture of your generator will have your CNN model. There are two neural networks which are competing against each other. So we'll look into what is generator. Generator is the heart of the GAN, where it attempts to generate fake data. As I'm talking with respect to image, we will assume as the fake image that looks real by learning the features from the real data. The main aim of the generator is to fool the discriminator. It has to fool the discriminator, generating a fake data which looks like a real data. We'll see how the generator generates a fake image or a synthetic image. The generator takes input as a random noise as the input and generates synthetic data. So as a beginner, we might be wondering how random noise will be able to generate an image. What actually is an image? An image is a bunch of pixels where it is stored in some fashion. If the images or the pixels are stored in some meaningful way, you get a meaningful image. If the pixels are stored in a random way, we get a random image which does not make any sense. The generator input is basically a noise. So the noise can be is basically a normal distribution noise. The heart of your generator. what does your generator consist of, or what it is basically made up of? It is the architecture of a generator consists of a deep neural networks. It is basically a CNN, which is made up of 8 layers. Basically, you'll have an input layer, output layer, and in between you'll have the 6 layers. But the basic functionality is the working of your CNN. The input layer and the output layer requires some activation functions. The activation function that we used was RELU function at the input and TANH function at the output. So basically, the output of your generator is to generate a fake image, or you call it as a synthetic image. Discriminator. The discriminator in GAN is a classifier. Again, it is also is a classifier that identifies real data from fake data created by the generator. The basic functionality of your discriminator is to discard the image that is generated by a GAN. It has to prove that the data or the image generated by your generator is fake. The discriminator evaluates the generated data with the real data and classifies whether the generated data looks real or not, and provides feedback to the generator to improve its data generation. What is your heart of your discriminator? Again, here also it is made up of a neural network only, CNN network. It is made up of 8 layers. Again, you will have an input layer. Again, you will have an output layer. The activation function of your input layer is basically a sigmoid function, which is a binary classification. Your discriminator will tell you whether it is real or fake. If it is real, it will generate a 1. If it is fake, it will generate a 0. The output layer is again a TANH function. So briefly what I can say is, generator is to generate a synthetic data or fake data. Discriminator is to find out which the data generated by a generator is fake. So both the generator and the discriminator will be working simultaneously. They'll be competing against each other. Generator is to, main aim of your generator is to fool the discriminator. The main aim of your discriminator is to not get fooled by the data generated by the generator. So we'll see how the training of the discriminator is done. This is the basic diagram of training of the discriminator. So what we do is, basically we train the real world images first with the discriminator. We block or we freeze the weights of your generator, and we train the discriminator with the real data. So the error that is generated is back propagated, so you can increase or you can update the discriminator weights. Secondly, how the training of the generator is done. The training of the generator is done. We block or we freeze the data weights of your discriminator. We generate the data using the random noise. Then we give the input or whatever data generated by your generator, the sample generated by your generator is given as input to your discriminator. The discriminator would have been trained with the real data. So there would be a comparison done between the image that is stored or the images that is trained earlier and the image that is generated by the generator. There will be a comparison done. If it is real, it gives a 1. If it is fake, it will give a 0. And the back proportion, the error with respect to your weights is back propagated, so that it is your generator can improve its quality of the production of the fake data. So applications of GAN. So as I said earlier, it is basically used in the generation of your images. You create a database of your images or the synthetic, whether you call it as a synthetic data. You can generate images that doesn't exist in the real world also. Second is the image to image translation. You're using a GAN called a cycle GAN, where you can translate your horse image to your zebra image, or vice versa, or you can translate your donkey image to your zebra, or zebra to donkey. There has been a massive amount of applications in the real world. Lot of research has been done by companies based on this. Some applications have been live, where you can give in the data and get the there are applications where you do the image to image translations. Next is you can use to generate frontal views. As I said, basically this generation of your frontal views are done in surveillance. Whether there is a, when you want to do surveillance, whether you want to keep eye on a person, you won't be getting the images as a frontal view in real-time images. So you can take side view images and using the GAN, you will be able to generate the frontal view of that images of that person. Next is text to image translation. So what happens here is you can give the image, say you want to generate some image, you can give the characteristics of those images in the form of a text, and your GAN will generate that image. So these are the basic applications of the GAN. There have been many applications which are in use, generated in real time for doing all these applications. So deep learning based human recognition using integration of GAN and spatial domain techniques. So I have implemented a paper based on GAN. What I've done here is I've generated a GAN image. We have generated a GAN database. Basically, we call it as data augmentation. We have created a database of GAN generated images using GAN, where we take the picture of a single person, and we have generated the 24 dissimilar faces of the same image with different text, what to say, with different poses or different characteristics, or with the different makeup and style. We'll keep the database of a single image. Then using that image, we'll generate using GAN. We call that GAN as DT GAN, domain transfer GAN. The basic working will remain same. You'll have a generator, you will have a discriminator. You train the generator, you train the discriminator, everything based on the and we have named that GAN as DT GAN, domain transfer GAN. Using a single image, we have generated a 24 dissimilar faces with a different makeup and style, and we'll be able to match using the spatial domain techniques. So this is the proposed human recognition model. One is the real-time data. This is a real-time image where actually it is given as input to the discriminator for training purpose. This is a random noise, as I said earlier, which is given as input to the generator to generate the image. And basically, this is the GAN block. So what is the function of your GAN block is to generate a image. So using this GAN block, we generated, I generated 24 dissimilar images, and we kept this as a database. This is the output generated image. These are the GAN images generated, and this images, a single image is stored in a server. As I said earlier, basically the face detection is face recognition or human recognition is used for surveillance purposes. You cannot store all the images with the different poses, different styles, as it may increase the memory load of the server. So what we do here is we'll store one image of a given person. Using that image, we'll generate different faces or the same face with a different color, makeup and style. So this is your output generated image, or you can call it as a GAN generated image, the database of the GAN generated image. This is the image that is actually present in the server. Next, we do the pre-processing where we convert our image to RGB to gray, again RGB to gray. Then we do the feature extraction technique. The feature extraction technique that I have used here is LBP and histogram. And we do the matching. The matching technique that I have used is Euclidean distance. So this proposed method is tested on the standard face data sets. That is your celebrity data set, JAFE, overall, ORL, and YALE. The overall database has a total number of 49 persons, and each person will have images of 10. Per person, you will have 10 images. The size of the image is 92 cross 112 pixels. YALE database, it contains 165 grayscale images in GIF format of 15 individuals and 11 images per person. Next is the JAFE, Japanese female face expression. This data set has 10 individuals with 20 typical pictures per person. The size of the image is 256 cross 256 with grayscale, and the format is TIFF image format. This is the celebrity data set. This data set has 100K RGB face images with the face with each image size of 128 cross 128, and the format is JPG. So as I said earlier, we have named this as domain transfer generative adversarial network. Again, the DTGAN is used in our model as two neural networks. One is the generator and the other is the discriminator. The generator is for creating new images and discriminator is to discriminate the fake images. The generator generates new images with the random noise as input, and the discriminator plays a real or fake image. The input to the discriminator is the generator image, and the image from the dataset. Now the discriminator finds out the real and the fake image among these two images. If the image is real, the discriminator passes it, else it sends back it to the generator for further training. So the DTGAN is used to generate several face images with the different styles of a single person. What is the object is to reduce the memory load, as I said earlier, to reduce the memory load on the server by keeping only one face image per person in the server instead of many face images. The real-time one face image of a person captured by a camera is converted into several face images with the different styles. This is several face images with different styles are generated by the GAN model. Effective identification of human beings with high accuracy for large database. This is a proposed algorithm. Input is your real-time images. Output is a recognition of a person. The random Gaussian noise and real-time dataset face images are applied to the generator and discriminator of the data. Again, since we are testing the image with the different data sets, the face images of any image is kept as a uniform size as 70 cross 70. The images generated by the generator are connected to the discriminator input. The discriminator classifies the generated image of the generator as real or fake. If the image is real, it passes the image from the discriminator output, else it does not pass the image from the discriminator. This process is carried out several times till the real image is generated. So what is the basic functionality of your GAN is to do the to generate a database, which we call it as a data augmentation. We have generated 24 dissimilar faces. Using that face, we have implemented our algorithm. So this is a local binary pattern. This is a feature extraction techniques. How this works is, these are all the image pixels. We'll be considering a central image. So this is a 3 cross 3 matrix. We'll consider a central pixel 82. Anything above 82 is considered as 1, and the below 82 is considered as 0. So we have replaced 120, 101, 96, 88 with 1, and the values less than 82 as zeros. Then we'll find the binary equivalent, and this is 225. In this way, we'll be doing it for 3 cross 3 matrix. This is a 3 cross 3 mask actually. Next is the histogram. The output of your LBP, the LBP coefficients of the image, that is 70 cross 70 or 4900. So we are converting this into 256 coefficients by applying histogram. The 256 coefficients are considered as the final features. So that leads to the reduction of number of features in effective recognition of a person, where less computation of the time is also done. Basically, we will see the image is represented from 0 to 255. Out of this 4100, we'll see we do the histogram and reduce it to 256 coefficients. Later on, the matching is done using your Euclidean distance formula given as below. As I said earlier, the DTGAN generates 24 augmented faces of image with one face image sample as the input. The spatial domain technique that is used, the feature extraction technique, is LBP, which gives you 70 cross 74,000 dimensions, and we apply LBP histogram on this LBP features and reduce it to 256, thereby reducing your computation time in identifying the human beings. Then finally, we apply ED to do the matching technique. And this is how we generated the GAN image with a different epochs. Epochs in the sense number of iterations. The generated image at the 100th iteration. This is the sample of the generated image at the 300th iteration. The same thing with the 400, 500. So basically, it is a iterative process. Generate a celebrity dataset image at the 100th epoch. So this is the image stored in the database, and these are the images with different poses and different makeups or styles. So identification of the person. Thus, we have applied LBP, original and the generated grayscale image corresponding to LBP image. This is the result analysis. So we have compared our algorithm with different data sets. As I said earlier, the celebrity data set, Jaffe, ORL, and Yale. The total number of images were 200. We took 200 images of celebrity. So the number of images that we were able to recognize correctly were 195, and the number of images not recognized or incorrectly recognized was 5. So the recognition accuracy was around 97.5. Here, for Jaffe overall, the number of images were less, so the accuracy was found to be around 100%. When the number of the images increased, the accuracy usually tends to decrease. So the proposed method was compared with the existing methods. We compared with the different standard papers. So this is in Wen. In the year, the technique he used was a discriminative common vector dictionary plus sparse representation based classification. And this was compared for overall face database. The recognition accuracy was found to be 96.54. Then Mohammed in 2008, then the technique used was PCA and BPNN. His recognition accuracy was found to be 96.90. Then Jan, Fan, Eta, and others, the technique they used was locality preserving projections plus maximum margin criteria for solving generative eigenvalue. The recognition rate was found to be 97. Jung Kong and others in 2020. The technique used was circular symmetrical Gauber filter and PCA neural networks. Recognition accuracy was found to be 97.5. Rangsi and et al. In the year 2002, the technique they used was DWT, HOG, and bit endiness. The recognition rate was found to be 98. So we used a method called as DTGAN and LBP with histogram. Our accuracy was found to be around 100 for an oral database. Again, the same method was compared with existing methods for YALAB database. For Mohammed, again, they used a technique called as PCA and BPN. The recognition accuracy was 97. Jun Fital with other in 2007 compared with YALAB face database. The technique used was locality preserving projections plus maximum margin criteria for solving general eigenvalues. The recognition rate was found to be 81.22. Santosh Kumar and others in 2017, the technique they used was Gabor wavelets and cross local binary patterns. The recognition rate was found to be 96.7. Chen and others, the technique used was a convolution between a face image and a set of LBP and low pass and high pass filter plus LBP. Recognition rate was found to be 97.3. Swaroop and others in 2020, the technique they used was DFT plus LBP. The recognition was rate around 97.64. And our method, as I said earlier, we used DTGAN LBP with histogram, and the accuracy was found to be 100 for YALAB face database. So conclusion, deep learning based human recognition is proposed using an integration of GAN and spatial domain techniques. The DTGAN generates 24 dissimilar faces which can be tested for recognition from a single reference image. The features of your face image are extracted using LBP histogram, and the features to be tested are compared with the face images stored in server using ED. So the matching technique we used was ED, and the feature extraction techniques was LBP and histogram. The performance of the proposed method is compared with the existing methods, and the superiority of the proposed method is observed. So basically, what I wanted to tell you is, using GAN, we created a database which we call it as a data augmentation. Using that 24 dissimilar faces generated, we compared with the face that is stored in the image using our algorithm, which involves your LBP histogram and ED. And the method the algorithm that we used was found to be superior than the existing methods. So these were the references. Thank you.
Any questions from audience? I think some Chala and Krishnaveni, they raised their hands. Madam, just assess kori. Krishnaveni, questions keltira?
ಮಾಡಿದೀನಿ ಸರ್ ಅನ್ಮ್ಯೂಟ್ ಅವ್ರು ಯಾರು ಮಾತಾಡ್ತಾರೆ
Ibru ಮಾಡಿ.
ಇಬ್ರಿಗೂ ಮಾಡಿದೀನಿ
I think by mistake they might have raised. Okay, Sharath, thank you very much for your
Thank you,
session.
sir. Thank you for giving me the opportunity. Thank
Within
you,
a
sir.
short notice, you could able to prepare your presentations.
Okay, thank you, sir.
Yeah. I think there are no questions for you.
Thank you,
We'll
sir.
move on to the next speaker for
Okay,
today's
sir.
session.
Thank you.
He was my student in a government SKGTI. Shivraj Kumar. He is working in the central government organization. He is actually a very young and dynamic personality, and he is working as technical assistant. Shivraj Kumar, are you connected?
Yes, sir.
Yeah.
Yes,
Be a
I'm,
little bit louder. Voice ಸ್ವಲ್ಪ ಕಮ್ಮಿ ಇದೆ.
yes, sir, I'm audible.
Yeah, you're audible, but I think you need to increase the volume from your side.
Yes, sir.
Yeah, we have a center for, he is working for Center for Artificial Intelligence and Data Science, Government of India, and he'll be delivering talk on role of big data in engineering. He happens to be very promising and very dedicated scholar, and has got a lot of ample of ambition in his life to pursue higher pursuits. On behalf of all the participants, Shivraj Kumar and the officials of DTE, I welcome you for this session. Now I request you to take over the session. Thank you very much. You can share your slides.
Yes, sir. Thank you. Good evening, all. My name is Shivraj Kumar. Today, I am talking about the role of the big data in engineering. So, when the big data, when we hear this word, it's a very important because when we see the decade back, there is no such way we have playing with the data. But nowadays, when our lifestyle changes and the technology is growing, we are applying the data in every aspect of our life. When we are seeing with a common man to the who are working a professional or even common man, everywhere the data plays a major role. So here we will discuss what are the big data, and so these are the contents I want to cover. About introduction about big data and how big data impacting engineering, and what is the big data architecture and tools, and what are the case studies presently we are using big data, and challenges of big data, because when we have a data, surely we have to have a challenges. And next, what is the future trends of the big data, and finally we will end up with the conclusion. So here is what is the big data. When we see, when we have previously, we have a normal database like a SQL. We have to store the data in the table because we have less amount of data. But now presently we have vast amount of data where it cannot fit in the relational database. Like a traditional database, the data cannot be fit because the data become different kind of types. So when we will say what are the characteristics, then we decide it is a big data. First thing, when it in terms of volume, for example, when the data is like in terabytes or petabytes in a very large volume, then we declare it as when we will think it as a big data. And when it come to variety of data, So nowadays, what is happened? We have a three kinds of data. One is structured, unstructured, and semi-structured. Suppose when we take it, the data in the form of tables, or have a defined structure, then we store it in a database, that is called structured data. When semi-structured, for example, we have data like JSON or XML, so that kind of data we want to store, that is semi-structured. And when we come to the unstructured, this is very important aspect, because nowadays everywhere where we found the data is unstructured, like images, videos, or like the data generated from the social media post. These are all unstructured data. To handling this unstructured data is very important, because from that we can process many more things. And storing this unstructured, for example, in our everyday life, every time when we have, nowadays, just see the mobile phones. Previously we have like 4 GB, 5 GB, or just some 4, 5, 6 to 16 GB phones. But nowadays, the even a small mobile phone having 128 GB of the memory, even some of the cases that is not sufficient, people are going with 256 GB. So it's increasing day by day. The usage, the generation of the data is getting increasing. So when the data is increasing, if we know how to play with it, then we can solve the many problems. The next thing is velocity of the data, the speed of the data generation, loading, and analysis. Actually, these velocity comes in, there are some organizations where they will handle with the satellite data and all, the continuously the data will be generated, so they have to process in when you are concerned about the security of security issues, or in banks and all, the in banks, what will be happened every minute, the very large number of transactions will be happen. So the every transaction will generate some data to loading it, analyze it, because every transaction is more precious. If anything, there is a loss. Then next we have veracity, so where the quality and validity of the data. And finally we have valence, how data will be connected the each other. So these are the main factors depending on the when we call it a big data. So at least it has to be meet certain characteristics of it, so we can specify it as a big data. Now we can see its role in engineering. So when it comes to the engineering, suppose these big data is mainly used for the analysis. So analysis is the main very important part everywhere we are using. Here I actually some examples I'm giving. After on later we will discuss much more details, where every different areas how we can apply the big data. Suppose in civil engineering, nowadays we are hearing the smart city construction or traffic management, because traffic management is the very important thing. Suppose when you will see you are traveling, you will open the Google map. Suppose in Bangalore it is very common, you can first open the Google map and see the trends. For example, there are 2 to 3 more than one path you have, but while choosing the path, you will see the best time, you will in a less time where you will reach, and with a less traffic. So how the Google map is providing is because it's maintaining the data, and it's maintaining the data and it's processing. It's a very faster way. It's storing the data and processing. So these are the way. So in our everyday life also we can use these applications. And when smart city buildings and all, suppose nowadays IoT sensors came into the picture. There are so many sensors, and when there is a data, to manage the many things will be possible. And when infrastructure monitoring, so these are the main things. And when we come to the mechanical engineering, suppose when we have maintenance of the machineries, suppose when sensor is generating the data about the qualities of the machines and all, so we can easily maintain the machineries. And when it come to the software engineering, then there is no words. Everywhere we are using data. For example, when you see the companies like main companies like Facebook, Amazon, Netflix, for example, when you see the Amazon, how it will suggest the product, because based on your searches it will keep all the data and it will provide the products and recommend the products. So next, and when it will come to the like now we are watching the TVs now. What happened, these apps like a Hotstar, Netflix, they will use the data every day. What you are watching, suppose your YouTube, whatever you are watching, it's keeping your data, and then it will keep an eye what kind of things you like, everything, and analyzing, and it's suggesting the videos and other interesting things. Now these are the main things where we are using this big data in every day. Even there are so many things when we are coming to case studies, we will discuss. Now, how big data architecture is there and what are the tools is there. Okay. So when this big data architecture, the first part is the data collection. So where the data will be collected, there are data will be collected from the various sources, like we are collecting from social media, we are collecting from online purchase, we are collecting data from data sensors, we are collecting from system logs. And not only that, even the organizations using the satellite images, okay, they are collecting from the satellites. So many ways. So every day, even every day, you are also in your mobile, if you were just aware or not, your data is also getting collected. Suppose if you are using Instagram or any app, then your data will be collected, and like every day your everyday history will, like there are data to recommend the next videos they will store. And suppose nowadays what will be happen, there are smart watches. So what will be they are using? They will be, they even a small watch having a sensor to collect the data about your heart rates, your how many steps you walking. There are every, even we are not like what will happen in our mobile. There are sensors wherever, if you are going to picnic, you are clicking the photos and you are storing. So these, when the last story is happening, then the data is collecting from the various ways. Now, what are the storages we will use? There is a very famous storage is Hadoop distributed file system. Okay, where this is the framework where the data will be stored in the clusters. Like it will be divided into the main cluster and different clusters, and data will be stored in it. And there are another nowadays, actually previously we used to use the SQL database. Now there are different NoSQL databases came into the picture, because the data is like a very large and we are handling different kinds of data. So when we have an unstructured or semi-structured data, we will use the NoSQL database like a Cassandra and MongoDB. And even we will use the cloud storage, because the cloud storage is very important. Every software industry now, they are integrating this cloud to store the data, because they are providing very flexible manner. So like in cloud, Amazon Web Service, S3. Now the first part, we are collecting the data, and when we are storing the data. So the next part is the data processing, because data processing is very important. We are collecting the data, but the data should be in a meaningful way. It should be in a order way. We have to be processed, and we have to be the keep to do anything. So now there are tools like Apache Spark, where the it will process big data sets with the speed. And we have a tool like MapReduce and stream processing. So there are Apache Kafka and Flink. These are the tools where data processing. For example, when we are nowadays, the AI and data science are the very trending job providers. So what happened, they are using these tools, like, so what they are doing, first they are storing the data. So these are the technologies, first they are using, collecting the data and storing, and next they are using these tools to process the data, means keep it data meaningful way, like any irrelevant data they will delete and make the data in proper way. Then once we have a data, now it's the time to analysis. Okay, so what we will do, we will do different kind of analysis, like descriptive analytics, for example summarizing historical data to identify the trends. For example, what this descriptive analysis, for example, you will see the like for example, where these will be, for example, if you are using an train app, suppose you are IRCTC app, when you want to book the train. So what will be happen, suppose nowadays what will be happen, we are getting the probability, suppose seats all got filled, now we want to be wait in a waiting list. So suppose when that some apps came into that, they provide the probability of the getting seat. How they are providing, because the past history data they have, and based on that they are creating the probability. So based on that probability, maybe when we are planning the traveling, then we can book the tickets. In that way, there are so many ways these descriptive analytics will be useful, and predictive analytics, like using machine learning to predict future trends or anomalies. So these like a predictive analysis mainly used in the banks and all. Now there is another one, prescriptive analytics. So then what will be happen, once we get the future recommendation, based on that what actions we can take, so that will be analyzed using prescriptive analytics. So here when we see uh, the top applications of the big data, there are different. Suppose in healthcare, one by one we will see how these big data will be useful in these sectors. When we see the healthcare, so what happening nowadays, even I said about the smart watches. So even these big data will be useful to you to the provide the personal health care. For example, what will be happen, even every day you are maintaining the data. Maybe today it is smaller, but when it is go every day, day by day, the data will be going to the larger. Suppose like when like there are some things like based on the symptoms of the disease, it can predict the future, like how danger it is and what are the different actions to be taken. Suppose when we see them like pandemics, COVID pandemic. In COVID pandemic, big data is played a very big role. For example, what happened? Everyone we have to see the zones, like they are distributed the like areas into red color, like a different zones. How they have did? Because they are collecting the data. The patient's data is to be entered, and where the patients will be more in that area, they termed it as the red zone. So next time when anyone has to be go to that zone, they will be very careful. So suppose this is already happened, for example, in future there may be any pandemic came, on that time we are ready with this AI technology, where we are collecting the data and analyzing the situation, or maintaining different aspects about the healthcare and providing the like facilities. So based on the data collected and analysis, so we can improve our healthcare system. Now when it came to the travel, so nowadays see there are like a Uber, Ola, or many travel apps came and they recommend you, and there are like what will be happen every day, they are keeping the data and they'll recommend many things, and they have to handle the data. Or if you have to plan, like you have to see the predictions, like even what is happening, weather prediction, whatever they have to do, they have to be keep the data, when vast amount of data will be stored and in the database. Now when we come to the education, even in education, when the students progress will be maintained, So every year, every test day, when the student progress will be maintained, and based on that, you can analysis you can analyze the situation where the student in which subject he will be weak, or in different trends what will be happening, providing nowadays what will be happen based on the trends, suppose recommending the recommendation of the course, for example, analyzing the future trends, and based on your skills recommending some more courses. There are so many analysis and analytical tools will be happening. They are keeping the data and providing analysis for you. And when it will come to the finance, it's a very important every day, because we will use this finance like a bank system, mobile bankings, because when banking there should be a data should be kept very carefully, and there is lots of transactions will happen. The banks will keep the data, and what will be the mainly thing, for example, when it come to the finance, this big data will be used mainly in the stocks. It's a very important in the stock marketing. For example, when people are investing in the stocks, mutual funds, you can see when you open the map, you will get the graphs and all, and even you will get every day how much it is increased, how much it is decreased, everything. There is a trend, and they will give the future analysis also. And when it will be in a retail market, when it is a shop nowadays, online shopping like a Walmart, they have to keep the stocks and all based on the data they are getting, they are keeping, and they will analysis the customer reviews. So what product customer interested, for example, there may be an same kind of product with multiple companies, and they will keep the eye on which product is selling more, and they will recommend customer reviews, and based on that they will keep the stock. And when it will comes to the entertainment, so in entertainment, these big data plays very big role. For example, when you are watching YouTube, so it will recommend the videos. Maybe YouTube will not take only your watch history, it will take collect from the data from Instagram, various sources, and it will recommend the videos and all. This is the way now every day we are connected, because when we are using smartphones or smart devices, even nowadays what will be happen, these smart homes will come. So every these smart homes various devices in your home will be controlled based on the data. So on the time every day we are increasing the you getting the data, we are generating data, and we have to process, and we have to maintain the things. Now, when it will come to the e-commerce sites like a Flipkart, Amazon, or these are the they will use your likes, dislikes, all. When you are connected to the internet, they are taking every aspect of your details, and they are keeping your likes, dislikes, and they are recommend, and they will recommend the ads which will more preferably suitable for you. So these are the, when you see the overall picture, almost when we see these, nowadays we are covering everywhere with the vast amount of data. Now when we have a data, it's very important, it's there is a challenges, because we have to maintain its privacy and security and the data quality, and we have to maintain proper infrastructure, and we have to maintain the people which have the skilled people to handle that. For example, if we are not keeping that, the data will be hacked. For example, we have many cases, some bank account hacks will happen, because when we have a data, it's very important to keep the privacy, because if you are just take into the OTP, single OTP can make your transaction with a very greater amount it will take. Suppose when recently what will be happened, there is a hospital called AIMS in Delhi. There is a data leakage. Though hackers, what will be happen? There is an organization when they are maintaining something great amount of data. Always the hackers wants to hack the system and take the data, because these data will be used for various purposes. So when we have the very big amount of data, the much challenges we have. Now, when we want to see the future of the big data, so now it is the era of the artificial intelligence. So artificial intelligence is making many things like analysis. So when the artificial intelligence is becoming very different nowadays, analysis we are getting, and wherever the recommendation system, because the learning will come into different types. The models are getting learned, and we are going to automation, and the we want to make the tasks to be very simple. To do that, we are making the collection of data and processing it. So in that, what will be happen? We have to be very careful with these things. What will happen? The rise of machine learning makes the big data even more growing, and so what we need is the more security. So it is required a better security. Then what will be happen? There is a extended adoption of predictive analysis. There are more analysis will be happen, and more cloud adoption, because what will be happen nowadays, everything will be in the internet. So we can't store somewhere, so we need a cloud space to store it. Even in your mobile, you can see, you can, all the clicks whatever you are making will be stored in a Google Cloud and all. Even we will get some free tier data, and we will finish it, and we want some people will be purchased, because we can't depend on a particular device. So on the time, what will be happen? The data will be stored in the cloud. Even see in education, what will be happen? The document clouds, like what there is the like Aadhaar card, everything will be stored in an app. There is in that app. So wherever we can go, we can access it. So these the when the data is when the technology is growing, we are collecting the data. So now all the educational institutes will be uploading in the documents in the online, and we are downloading. So we do when we require some document, now we are reducing the efforts. Easily we can get it. And more advanced big data tools, there are planning for different tools. So this is about the different aspects of the big data. And when I want to conclude, so this is the trend where we are using increasing the big data in day by day. For example, when in 2010, it is a very less amount of data, where it is in a zettabytes. So when day by day, see every year, even now, when you see the latest trends, like a 2022 to 24, in a within a 4 years, we are increased a very vast amount of data. And maybe in upcoming years, like in 25, 26, because everywhere it is using. When you want to maintain the country's security, then the satellite images, everything, when you will watch the cricket, so everything, you will see the moreover graphs, they will analyze in advance every ball. So everything is analyzing and getting know what will be happening based on that structuring the things. So this is about the big data, and thank you.
Thank you, Pastor. Any
Yes,
questions
yes.
from audience?
ನೋ ಸರ್ ಯಾವುದಿಲ್ಲ ಸರ್.
Yeah. Thank you very much, Shivraj Kumar, for your informative talk.
Thank
And,
you, sir.
on behalf of all the officials and DTE staff and students, I thank you sincerely for sharing your knowledge on big data. Thank you very much, Shivraj Kumar, once again.
Thank you, sir.
Yeah. We have
Thank
next
you for
speaker.
providing this opportunity.
Yeah. Thank you, Shivraj Kumar.
Thank you, sir.
We have next speaker, Dr. Nagappa U. Bhajatri, the professor of Computer Science and Engineering, and he is working in Government Engineering College, Chamarajanagar. Hello, professor, are you there?
Hello, sir. Hello, sir.
Yeah. One second. Just
I am adding,
yeah.
sir.
You can share your screen if you have slide.
Thank you very much. Thank you, Professor, about my introduction, Professor Basuraj, and also the opportunity for giving the small talk on the as a part of the AROHAN 2024, the lecture series 15. So now I am going to talk about my part of the research work. The title bears the discriminatory projection of camouflage texture through line masks. So basically, the camouflage images going to be decamouflage. So there are several mathematical models are available. One such simple statistical model I want to be extend here. That is a line mask. So continuation of this going to be a second slide. So I have a flow in this way. I have a little definitions about camouflage and abstract, and quickly move to the model we can build for the what kind of decamouflage technique we want to exercise here. So with line mask, that is as I told, it is based on the statistical information, histogram, regression of lines, right? So such simple statistical formulas we can expound here in order to find out the deviations which responsible for creation of the camouflage, which is a sometimes it is a nature gift, sometimes the military also making use this. So knowledge of fusion for camouflage detection model going to be extended, and there are some experimental evidences are there over the synthetic data as well as the natural data, and eventually we can conclude this. And coming to real work, we can have, so camouflage is obscuring the objects in a background. So background and foreground have a similarity. So sometimes animals may use that is, especially reptiles and some of the animals, which will be, they have a nature gift for them. So that is a visual organism or object to remain indiscriminable from their surrounding environment. Naturally, most of the times, so it is a preventing attack from the predators. So that is also possible. So that is also nature. Also works because it creates a visual confusion. The human visual system going to be confused due to the foreground similar to the background. Whatever amount of foreground may be there, but it is submerged in the background. So that is will create some confusion for the human visual system, and it does not make a thing invisible, but it make a disguises the recognized form by breaking up the visual outlines. So boundary, the foreground, whatever the object boundary is there, no? So that looks invisible in the background. So in daily experience, we have been experiencing that is disguising one thing to two things in one as a one, three as a two, and so on. That may be a multiple submerging of foreground in a background possible. Most often, it creates a confusion, as I told. The background called blending and kind of the object and another mimetic resemblance. It causes a single object to divide into meaningless fragments. So continuation of this, today also practiced by and large detect such defects or camouflage is visual inspection, inspection, which is highly erroneous. Due to the once a visual system is in the state of fatigue, their concentration level gradually decreases and fails to detect the such defects. And also, we can say it is a blending defective textures with ambience texture results in a camouflage. So normally the gray or color distribution of pattern of the images fail to reflect the considerable deviations between the foreground and the background. So that demands improve the strategy for texture analysis. So it may be a texture, or it may be a color, or it may be a shape, right? So here we are going to be consider texture discrimination. Here we are erected an initial enhancement image that employ line masks. I will elaborate in the subsequent slides that line mask, which could result in a better discrimination of the camouflage portion. It is a one effort here we have made, that is. Eventually, a gray value distribution pattern are analyzed in the enhanced image to fix the camouflage portion. So make a zones, make a boundary, or a defect portion or non-defect portion, make a segmentation so that we can reveal that there is some portion was hidden in the background. That is as application wise, there are plenty of application in the military. So as we know that military camps or soldiers or their weapons have a vegetation. Due to naturally hide them in the background, they can cheat the enemy satellite. Neighboring country satellite may fail to identify our military camps or military activities. So that's why they are go for green color. Secondly, there are a lot of applications are available in the agriculture field. So we can know that drone systems are employed to spray the pesticides or identify the some of the disease happen in the plants. Right, that can also identify. And also a lot of other, there may be in the medical practitioner, they go for operations, so they can also identify the blood and the muscles which happen during the operation time. So like that, the plenty of applications have dragged our attention. So in view of this, we are going to build a model for the such defect or camouflage or the foreground obscured in the background. So which will be failed to identify by the human visual system, which will be confused aesthetic. So in that sense, there are plenty of models have been evolved in the literature. One such effort here going to be evolved, that is a problem of detecting a camouflage portion, which may itself is a very small amount in a static image, in contrast to the motion camouflage problem too. Perhaps this is a more challenging situation. If the decamouflaging has to be completely carried out in an unsupervised way, that is less information is there for the machine to learn about the foreground as well as the background. So that's why we can say it is a unsupervised way or partial unsupervised way, that is. The unsupervised, we mean that you do not have any information about the either the normal background or the foreground image, or we can say defect oriented or camouflage, or they have a similarity with the background one. So here made an effort semi-supervised environment, in the sense that assume that we know that property of region or surface under normal condition, which very small percentage of region represents the camouflage or defects. Maybe small percentage or this percentage varies sometimes. Normally in nature, it happen very small percentage of foreground will be there. that is, we know that is a nature gift for the most of the animals. So continuation of this, the discrimination model based on the texture here. There could be a possible several efforts. Could be a texture orientation, maybe a shape, maybe a geometrical shape or irregular shapes. Now, normally there is a lot of irregular shapes might be happen in the nature. First, some of the synthetic image we have considered in the experiment purpose. That is maybe some of the geometric shapes may be quite convenient to improve the accuracy. Color properties also going to be a play role here most of the time. So importantly, the problem of texture obscureness, obsceneness with a similar background, which is a most challenging one, obviously. So concentrated on improving the discriminatory enhancement of camouflage texture, where the texture can be discriminated with those via line mask statistical effort. So once they identified, projected through the enhancement. And here we are going for the histogram features. So histogram will be obtained for that both the background as well as the foreground. In other words, the normal image and the defected image, or histogram, camouflage image. For them, we can take a histogram, and result of image classification and subsequently decamouflaging will be taken place. So histogram features based on the classification is a regression based histogram, right? So we'll take a histogram and generate the cumulative histogram. Once a cumulative histogram there, you can draw a line for the that fitting, that regression line fitting, right? With a simple formula mx plus y is equal to mx plus c. So once we constructed the regression line, so we'll get a regression line for the normal image, a regression line for the camouflage image. So those lines will be help us to identify the camouflage portion, need to mark that or segment that. So that two regression lines will be definitely help us to by getting a distance of them with the similarity measures, either maybe city block or maybe Euclidean distance or Manhattan, or plenty of formulas are there, or Dirichlet distance. Using them, we can find the distance between these two histogram lines, and we will able to help us to discriminate them. So let me see that. So the simple global way to have, there is an image we can decompose into say disjoint partition or the partitions. Design a line mask. That line mask will be help us to discriminate the normal as well as the camouflage portion. So the line mask have an angle, could be a 0 degree, 26 degree, 49. For example, you are saying that is. So that all depends on the what type of orientation of the text happen in the image. So we are approximately exercising the different line mask over them, then it will be going to be give some clues to there is a presence of defects or camouflage portion will be there in the background as a foreground as an object, or camouflage portion we can say. So for example, some x degree we can enhance the image, extract the features. So those features will be help us to histogram, cumulative histogram, and fit the line, regression line. So that regression lines will be help us to extract the knowledge. Similarly for other angle, similarly for various other angles, will be compute. So eventually we will be club them, we will be fuse them. So once knowledge will be formed, that is a fused one. So there we'll get a the camouflage set as well as the uncamouflage set. So there with the clustering technique, we should be able to identify them. Segmentation of the camouflage region, we will be able to notice here. So this is a global strategy which we have exercised in this effort via line mask to find out the defects in a given image, right? So that will be happen. Let's take an example. The mask size normally 3 cross 3, 5 cross 5, of course. So for that we have a horizontal line that is a 222, and also 45-degree line, that is 45-degree line. So we have a diagram. So vertical lines, that is 22. So these are the masks going to be convolved over the camouflage image. So that is a mask sum is equal to little mathematics. I'm not going to be deep in mathematics. So then we have a window. The W or mask coefficients will weights, and y1 to yn are the gray values which are present in the image, right? So the result of the mask is reflected through its center. So, for example, the 30-degree mask we can place over the image and convolve it, and we'll get a different texture. So, in such case, we should go for a bigger mask. And this one in the table we have different size of mask we can have, that is. So, deciding the mask coefficient. So that is we have a table we made, that is mask size we can have. So mask size of 3 cross 3 to 25 cross 25. So for that we can achieve a different degree, 0 to 180 degree. So approximately you can construct that is a mask. So consider here a figure which will be find out the pixel distance between 2,1 to 4,5 in a 5 cross 5. So here we have a what is 5 cross 5 mask, and here we have a weightage approximately computed, and this is a we have a slide that is 4 4, that is approximately this line pass through these coordinates, right? So these coordinates, so we can say approximately that is a some 30 degree, so on, that is we will see that 45 degree, sorry. So this orientation line is approximately less than 45 degree. So equation of line y is equal to mx plus c. So we have a tan inverse up to 26 degree. Hence this is produced the 30 degree line approximately, not accurately. So we have the model here. So there is image x and y direction. So we place a mask over the image, and that will be compute. And after computed, the central pixel will be get affected. So that will be a get affected. Will show the information defect portion if it is, right? So I have tried some synthetic images. So here a normal image is created with the alphabets UV, and can observe there. So similarly we have a defected image. So at the center there is a small defects happen. So but human eye cannot able to discriminate them. So we have a mask convolved over this, and over a normal as well as the defect, and different degree, 26 degree, 45 degree, we have found, that is. So there is some information revealing here. So there is also 90 degree, 135 degree. So the different degree effort made here. There are some clues you are getting, but for the bare eye, it is difficult to find out that. For which we will go for that histogram, right? Histogram. So we have this image. We got a histogram and the cumulative histogram, and we will fit the line. The lines will get for the normal image or the camouflage image. So we are observed here. So this image is decomposed into disjoint 15 blocks. 15 blocks. So out of which we have exercised some hierarchical cluster algorithm. So that hierarchical cluster algorithm once generates the clusters blocks. Those blocks we draw a dendrogram. So dendrogram says that is a similarity between the blocks, right? We have total 16 blocks. 16 blocks are there. So these blocks will have a similarity. So for example, here we can consider the block number 11. Block number 11 form a separate group, right? So block number 539 have a separate groups. So all other some blocks never participate because they have a more similarity with their textures. So So from this dendrogram, we are able to find out this length. It is the similarity. So we can say that is a span. 30% of the threshold we have set. That is. So in this picture, it may be a small poor readability is there. In the subsequent slide, I will make a more effort. That is. So the threshold have 30%. So before that, we will get a two-class problem. It is a division of two-class problem. One is a defected area. The other one is a undefected area. That is a ultimate idea to behind to separate out. So similarly, the 26-degree line mask we can observe here. So there is a 11 form separate cluster and 1, 5, 9, 15 they form separate cluster. So finally, we cut at a particular span of that dendrogram. We'll get a two-class problem. One is a defected and the other is a undefected. So similar effort made for a 45-degree line and 135-degree line. So on this is so and also different orientations mask over the image we tried. That is so based on the percentage of chemoplace, we got the information here. 3x3 lines we have a more informative. For the more percentage of chemoplace, it's showing the more discrimination power is showing. Similarly, we can have a mask size varies here. So 90-degree, 0-degree we tried. So here 90-degree line mask or a different size, we made an effort. That is. And similarly, we have 135-degree made an effort here. And different mask we have 3x3, 5x5, 7x7, 9x9. So these are all the effort made here. So extraction and eventually we can fuse them here. So here we made the knowledge extracted and made a fusion here. There is a k number of orientation 0 to 135 made. That is so cluster form here. So there is a number of samples in a cluster, and US is a uncamouflaged set, CS is a camouflaged set. So we can observe that is cluster 11, that block 11 comes under the camouflage set. And also wherever 11 is there, the other 1, 5, 9 also 11, 3 also form a cluster, camouflage set, right? So here you can observe, so 11 is almost all, it is a defect portion. So all of that we can combine here. So on camouflage set and the camouflage set. So on camouflage set will be we have 1 to 16 except 11. So 11 comes purely under a camouflage set, right? So camouflage set. Along with that, the other one we have some portion of camouflage there, but clearly 11 one block is the camouflage set. So with the little mathematics, the fusion of knowledge via intersection of K cluster on camouflage and union of K set, camouflage set or defective set, that is. So this is a camouflage set and this is a uncamouflage set. So here we can measurely 11th one block, this shows the maximum information which comes under the defective or camouflage portion. Comprehensive algorithm. So I have shown the flowchart in the previous discussion. So that will be rewritten in the different form. So we can divide a L into L disjoint blocks and get the orientation mask, run over the block, and we will get a histogram for that each block, and cumulative histogram we can obtain. From the cumulative histogram we can fit the line, the regression line. So that will get a slope, the intercept. That will be help us to understand the portion which is have a defective or non-defective. So the lines going to be different. If the lines are overlaps, no camouflage or no defects in that, like that we can interpret that. Perform a hierarchical complete linkage clustering. There are plenty of algorithms are there. We can borrow one such hierarchical algorithms we have borrowed here. So that is as I told, we have a two-class problem. So for that we can cut the dendrogram. So we have a 30% threshold. So that after measuring that span, we'll get a 2 class, that is. So we'll able to declare that chemoplace portion that is a 1 class, that is a 1 class, and other class it will be a background or non-chemoplace image. So experimental validations, I quickly go through. There are some experimental we conducted over the synthetic as well as the natural images. Let me see that. I have implemented this via some of the available systems. That is a 2.99 gigahertz volt system having a small amount of memory, 512 as a main memory, right? So experiment 1. So here we have taken constructed a synthetic image with the exclamatory mark, right? Exclamatory mark. So this image constructed with the pipe symbol and the exclamatory mark. So those are look similarity. So here we have constructed the image that is hidden in the background. Difficult to discriminate two symbols each other. Let me see that. So that is a image will be divided. That is a 120 by 120 image. Of course, we can normalize for the experiment purpose. I am saying that is so 120 by 120 image we split into 40 into 40. So over them we have convoluted the 3 cross size. So here we have a example. So this is a pipe symbol as well as the exclamatory symbol. So in the middle we have pipe symbol, and the surrounding that is the exclamatory symbol. So we made into 9 blocks, equal blocks. For the 0 degree, we have unchemoplace section set and unchemoplace set. So the chemoplace set is a block number 6. So 1, 2, 3, 4, 5, 6, right? So the approximately this is a 6th block that will so have a dominance over that. And also 4, 5, 6, approximately 4, 5, 6 have together as a community. It represents some chemoplace set. So quickly that we convert that we have exercise 0 degree, 90 degree mask. So over the image, and as usual, we constructed a histogram to the cumulative histogram to regression line to. So line will be available with help of the intercept and the slope. So we can able to discriminate the blocks, right? For example, 6 blocks are there, and 6 set of regression lines will be get, that is for the normal as well as the defect one, that is a pair one. That we can discriminate them, right? Which help us to, and I will be exercise the clustering algorithm. This process will be conduct for the knowledge fusion, as we decided 30% threshold we have fixed because we have experimentally found that empirically found that 30% is enough to say 2 class sufficiently divide the given the foreground as well as the background format to 2 class parameters. So that is given in the 5C. And as I told that block number 4, 5, 6, this is a 4, 5, 6 form separate cluster, that is C2, which is formed 90 degree, and these are where suspected to the defective. So by observing this, we can geometrical shapes we have line on 90 degree, so that we exercise that 90 degree, then we are able to find out the results, which is how the clarity here, the foreground and background we are able to discriminate here compared to the original image. So that technique has helped here. So this have repeated by various authors. So authors have finally adjacent situated chemoplace sectors were fused together in a final image. We can get that is. So that is experiment 1. The experiment 2, we have taken a tiles, undulated tiles. So that is a natural image, ceramic tiles. So this we have divided into 25 blocks. So 200 by 200, and each block have size of this 20 by 20. So we have, so this portion form a cluster. So 14, 15, 16, 17, 18, 19, 20 form a separate cluster. So other form a same cluster. So we form that is the 2 class we can able to discriminate. So after that, they segmented those this class, this block.
Sir, sorry to disturb you. Another speaker is already waiting.
Okay, sir.
Can you just wind up, sir?
Okay, sir. Okay, sir. So with help of this, I can able to complete this segment that undulated parts of the tiles, which will happen in the tiles classification happen in the most of the industry. Okay. So similarly, so due to the time shortage, so constraints, I will move to the last experiment. So that is experiment 5. Here we consider the natural images top of the matchboxes which flood in the market as a substandard product or duplicate one, right? So these are we have considered. So this is a defective matchbox. So this will be split into 16 blocks. For that we drawn that is a dendrogram. So then from the dendrogram we are able to identify the block number 8 and 11, which is able to have a you can observe here all are home light, for example. So you can only consider these two. It will be a home stick. There is some English alphabets have changed. That is, so we should able to the majority will be the standard product or maybe undefective or natural product. So which have some substandard product may be rushing into the market, which will be make a confusion for the human eye systems, so that they gain the profit of their product quality, So coming to the conclusion, so we made an effort to reveal the obscured image or projected through the discriminatory feature enhancement, that is a line mask with different orientations we consider, enhance the binary discrimination features. So we have considered the textures which are convolved with the line mask to enhance the visibility of the texture with their variations. Further, to process to obtain the histogram regression line and generated from these regression features through the clustering, which is popularly available hierarchical clustering techniques. That is a semi-supervised we have exercise. Identification of the texels could be very good features, able to have that geometrical orientations, shapes orientation, which help us to enhance them. Even we can extend for the natural images also. So the results on several data sets we have attempted. This approach capable to correctly spotting the chemical regions as a part of the future work. So we can directly extend this for the most of the natural images which happen or given by the nature, most of the animals or most of the reptiles, even for agriculture applications, or in order to find out the defect portion of the leaves or crops. So that is a more worthwhile to discuss this. So there are plenty of references are there. Here, a few of them we have highlighted here. So with this, I will convey my thanks to the organizer, providing a opportunity to share some of the work we have extended here.
Any question from the audience? So thank you, sir. I think there are no questions. On behalf of our Directorate of Technical Education, and all the officials, and all the participants who are here, I thank you for delivering such a wonderful talk. And we have next speaker, Dr. Jyoti AP. She will be delivering on a talk on machine learning. To introduce her, Dr. Jyoti AP completed her PhD in 2020, a master degree in 2009, a bachelor degree in 2002 from Visvesvaraya Technological University, India. And she is currently working as faculty in the Department of Science and Engineering, Computers and Engineering, Faculty of Engineering and Technology, MS Ramaya of University of Applied Sciences, Ramaya Technology Campus, Bengaluru. And she has 17 years of experience in teaching and published many research papers in journals indexed in SIC, SCI, Web of Science, Scopus, etc. And she has also presented papers in several national and international conferences. Her interests include wireless sensor network, MANET, IoT, AML, deep learning. And she is a member of several professional bodies, and she also wrote several reputed journals and conferences. And she has authored a textbook in Springer, Wiley, IIT, CRC Press, and CRC Press, Thailand Francis Group. And she is serving as an editor for reputed journals and publications. And she is also a resource person in India as well as in abroad. She has received Best Women Researcher Award and several excellence awards. And she has Indian, Australian, German, and UK patents granted in her name. So it's a pleasure to have you, honor to have you on this session, madam. Madam, are you
Thank
there?
you, sir. Thank
Yeah.
you, sir.
Yeah. I think I request you to just take over the session.
Yeah.
You can share the screen if you have.
Are you able to see my screen, sir?
Okay. I think you can hold it landscape. No, it's portrait.
Yeah, 1 second, sir. I'm just playing it.
Yeah, now it's clearly visible. Okay.
Yes, sir.
Yeah,
Can I
thank
start, sir?
Yeah.
Yeah, thank you so much for that wonderful introduction of mine. And today we are going to talk about current trends and applications of machine learning. So machine learning, as all of you know, it is part of the artificial intelligence, as a subsystem of artificial intelligence. And as sir has introduced, I am from MS Ramaya University of Applied Sciences from the Department of Computer Science and Engineering. Today I'll be just going through the basic definitions and how machine learning can be used for different applications, especially for the Google apps that we are using day to day life. And before starting with the applications, I just want to brush up about the machine learning, different types and all different algorithms that you can use. So machine learning is basically is a software application which will make us predict things more better. That means it is similar to training a kid, as such, you can say, because when the child is born, the time the mother, how she will train the kid, she will say, she'll show some apple and tell the kid that if it is red in color, round in shape, it is an apple, right? So you're training your kid's brain, making it understand that it is an apple. So similarly, we have to train our machine in machine learning, and we have to use that trained data, and you have to test again with the new data that we have, so that whatever the output we are getting, we can just say it whether it has been a labeled data or a non-labeled data, and it should be able to predict it in a proper accurate way. So that is a basic definition of machine learning, as you can say. But when it comes to mathematically speaking about machine learning algorithms, you can say that a computer program is said to learn from this experience in the sense that I was telling you, we need to train our machine, right? So that is the experience. So past experience we will be using to do a particular task, say T, and we will do the performance measure, which we calculate it as capital P, and whatever the improvement that happens, so it leads us to more accurate results in the predictions that we are going to make. So this is somewhat related to the mathematical aspects of machine learning. So only difference between the traditional programming and machine learning is, in the traditional programming we use the data and the program to get our outputs, but in machine learning we use that output back as an input, so that we train it again and again and make our model still more accurate to do the predictions whatever we are doing, especially in healthcare and other domains. Prediction is has to be 100% accurate, as we are playing with the lives of the people, right? So having a good accuracy is very, very important. So coming to machine learning, will having the training data, and we'll have a learning algorithm, and the trained machine, whatever the query we ask the trained machine, it should be able to answer us. That is nothing but the prediction that we are going to make. So one example I've shown here. So you can see that there are few apples, there are different kinds of fruits you can see. So you can do the classification using the machine learning algorithm, and also you can use it for some shopping applications as shown in the second diagram. Like you can have a discretion between the different types of handbags, shoes, and gaps. So why all this is required is the data is playing a major role nowadays. So whatever you speak, your mobile will start giving you the advertisements related to that. I hope all of you would have gone through that experience, right? So here, whenever I search for a bag, it will give you start giving you the advertisements related to the bag only. So how that is because it will start learning that the customer is very much interested in handbags. So they will start giving you the advertisements related to that. So that's why this data is used nowadays for customer satisfactions as well, and also to promote their products. So one more example is NLP. NLP is nothing but natural language processing, which is a subset of again machine learning. So here is one classical example, because it is very hard in this set of data I'm showing you over here to say which makes a 2. But how the machine learning will help us do this, because humans, it is very difficult to find out what is it, right? So in generic flow, if you have an image recognition algorithm, if you have a handwritten 6 as shown here, the image recognition would give you the labeled outputs as 1 to 9. So this labeled outputs are the trained data outputs, and based on this outputs we will feed it back as an input and just check with whatever the new input, that is the handwritten 6 I'm showing over here. So that out of the available labels we are able to get the proper output, that is a prediction saying that it is a 6. That is a computer generated labels that is shown on the right hand side. So it would be able to predict it is a 6 properly using the ML model. And these are the main advantages of machine learning. It is having a continuous improvement, as I told, because the output is fed back again to the input. We try to make our model much more accurate. Lots of machine learning algorithms we are using. So we'll be seeing about that also. Automation for everything, because once we train and test it, we need not have to have an human interference in between. So everything becomes automated. And trends and patterns identification. So as I was telling you, this bag, shoes and other things, so depending on the patterns, the trends can be set and it can be used for the customer support. And a wide range of applications are there with respect to machine learning, which I'll be discussing later. So when we can use this ML, when human expertise does not exist, so something like we are in Mars or somewhere wherein human intervention is difficult, during that time we can use the machine learning algorithms. We can use it for speech recognition, we can use it for personalized medicine, we can use it for genomics. So many applications are there, unlimited applications I can say. So this is the basic structure, wherein in the phase 1 it is nothing but the learning phase, wherein the training data would be given and it would be pre-processed, and learning happens in 3 things like supervised, unsupervised, or it can be even the reinforcement learning as well. We'll do the error analysis if there is anything using the performance parameters like precision, recall and other things. And in the phase 2 we do the prediction, whether the new data that has been given is actually matching with the model or whatever the label that we had obtained during the training. And this new data is considered to be the test data and would be doing the prediction of the data. So this is the generic working, I can say. So how exactly we teach machines is only in the 3 phases. First we take the data as an input, then we do the abstraction of the data, that is we try to make the data in the structural format that we require and use the ML algorithms, and this is the elementary learning phase. And then finally we use it for the practical application, wherein we check with the validation. So basic steps in machine learning. First, the diagram I'm going to explain, it is related to the data pre-processing. So data, whatever we are doing, we are collecting it, and this data has to be done with the data munging. That means little bit of pre-processing is required. Pre-processing in the sense, if you have any unused data, or which is not useful data, or redundant data, missing data, or you have any outliers, all those stuff has to be removed, and only useful data needs to be extracted. And after that, data conversion has to be done so that all the data are in the same format, And the tabular data, it is nothing but the data and the labels. So labels we are going to create using this. So preparing the data, I just explained you. And next will be the training a model. So here we'll be using the out of the total data set that we have, we will divide it into train and test portions. And mostly training data would be more compared to the test data. And the test data is like the new data I was showing in the previous block diagram. So after doing this, we'll be evaluating our model. That is, we are trying to use the test data and try to find out how much accurate our model is, depending on the performance of the data. And finally, if any improvement is required, it is again made the modifications, and we will try to improvise the performance. So types of machine learning algorithms include supervised learning, unsupervised learning, and reinforcement learning. So supervised learning, it can be either regression or classification. Regression is for the continuous evaluation, and classification is like you try to divide it into different categories. And in unsupervised data, you have something called clustering. That means we try to cluster or group together similar kind of data. And one thing difference between supervised and unsupervised is supervised will have the known data, that is it will be a label data that we'll be getting in the training phase, and we'll be matching that label with the input in the next phase and trying to get the output. But in unsupervised data, it is totally data driven, and it does not have any label data. And in the reinforcement learning, the algorithm will have to learn and react to the environment. So here basically some agent kind of a thing will be there, which will be given some rewards, and based on the reward it should be able to find out what is the thing. So I'll just show you through this block diagrams so that it is easy for you to understand. So in supervised learning, so there is a known data and the known response will be there, and the new data will be giving to the model and checking it whether the output is matching with the particular thing or not. So that is the supervised learning, wherein we'll have the labels. And in unsupervised learning, as I told, we'll be doing the clustering. That means apple will be grouped in one cluster, bananas would be clustered in one more, and mangoes would be clustered in the other one. So this is like we are trying to group the data. Sorry. So in the reinforcement learning ML algorithm, you can, I've just taken an example of the dog as an agent. So this can be any gaming application as well. So you have some something to be done to, in order to, that means here this dog is sitting over here, and it is a state of the dog. Sitting is a state of the dog, and the action it has to do is it has to walk all the way to get that particular reward. So here reinforcement learning can be used. One example, as I told, is in gaming things. So that to earn a reward, we'll have to do some task. So supervised learning models, it is a predictive model. So one example I have given here is the decision tree algorithm. So decision tree algorithm is used here just to find out whether a particular given data is a dog or a cat. So if it is barking or not, we are going to check in the tree. So initially we are going to check whether ear is pointing, yes or no we will check, and then we will check if it is barking. If it is barking, then 100% it's going to be dog and not a cat, right? So we will use the table on the right hand side to use that. So we will just start creating the trees depending on the decision that we have to make. So lots of applications are there for this particular supervised learning. So like text categorization, face detection, signature recognition, customer discovery, spam detection, weather forecasting, predicting housing prices, so stock prediction. So lots of examples you can have with respect to the supervised learning models. So as I was telling you, so this is the overall block diagram for the supervised learning model. So as I was telling, whatever the input data is there, we will do the feature extraction of the vectors. That means whether it is a pointing ears or whether it is barking. So that example of the dog or cat I just gave you. So those will be considered as a feature vectors. and that will be loaded to the machine learning algorithms along with the labels, and then we do the predictive model. We'll be using the predictive model of the ML in order to find out what is the expected label. So label here would be the dog finally in our example. Unsupervised learning and descriptive model. Here, as I told you, we will be trying to do the clustering. So depending on the type of the data, we will be trying to find out similar kind of data sets that are there, and based on that we will form the clusters as shown here. So blue colored ones are one type of cluster, and green colored ones are one more type of clusters that we have. So it is a visualization of the cluster data that you can have, and the red colored one are showing you the centroid of each of those data. Sorry, there's something wrong. One second, I'll just rejoin again. There's something problem with this thing I got. Yeah. So one example I'm giving here is the k-means clustering, which uses the centroid and also uses the Euclidean distance calculation between the data points in order to find distance between the centroid and the data to form the clusters. So this is the basic block diagram for the unsupervised learning model, wherein the output would be like likelihood of or the cluster ID, or whatever is the better representation for us, that will be the output of this. So in the reinforcement learning, as you can see, so this is how it looks like. You will have the environment, you will have to percept from the environment in which state the particular agent is in, and if he wants the reward, he will have to do some action. So one example here is this Markov decision tree as is shown here. So Markov decision process is shown as an example, wherein there are different states. R is equal to 0, R is equal to 1, R is equal to -2, -3, are all different states that agent will go through. So in order to have a particular what do you say, reward, he'll have to move from one state to another state. So that is a basic understanding of reinforcement learning. So one more example for reinforcement learning is just for your better understanding, I put this. So before conditioning, if you just say food, your dog would be unconditionally giving a response that it wants to have the food. So if you before conditioning, if you just ring a bell, it will not do any response. But food along with bell, if you do, then it will understand whenever the bell rings, there it will be provided with the food. So conditional response will be there from the dog that whenever the bell rings, it will go and have the food. So this is how we try to train the model in the reinforcement learning. So an autonomous agent should learn to choose optimal actions in each state to achieve its goal, and it does it by trial and error method, interactions with the environment. So here one example is Oompas world, you would have heard about. So if it goes into a particular pit or something, it would be losing points in the gaming of the Oompas world, right? So it is the same way. So a generic comparison of machine learning algorithms has been listed in this particular slide. So you can see that machine learning algorithms in supervised learning, it will have the label data, and regression and classification are the two types of problems it is going to address, and external supervision will be the training type, and approach would be map the labeled inputs to the known outputs. And in unsupervised learning, machine is trained or unlabeled data without any guidance. Association and clustering are the two types of problems it's going to solve. and unlabeled data is there. So no supervision is required. So it has to understand the pattern and discover the output by itself. And in reinforcement learning, an agent interacts with its environment, performing actions and learning from errors and rewards. So if it is going to lose any points, it will learn by itself that it should not do that, do something else to get a better reward. So that is why it is called as a reward based, and no predefined data would be there in the reinforcement learning. Few examples are like Q learning is one of the example for reinforcement learning. It follows a trial and error method, as I told earlier. And coming to the applications of machine learning, there are a lot of applications. So few of them I will just share it with you. So only I have taken example of the Google ML. But as a faculty members, I would suggest that you can do a lot of work or the research work related to machine learning. Along with your students, you can do it. So there are lots of accessibility, like GitHub is there, so which will give you the code and the Python and other things. So one example is Google Translate. So if you are visiting any other place, automatically you can convert the language to your known language like English and all, and you can do it. So this is a simple example of Google Translate, which is already available, but we can do lots of projects using this again, wherein we can train our machine to understand different languages. So NLP is booming up like anything. So natural language processing, I'm just giving you the research avenues through which you can all try doing researches. And finally, I'll also tell where I am also working for few of the research projects later. So Google voice search, so you can just if you don't want to type, you can just speak using the Google voice search. So this is also one of the example of machine learning. So how it will identify your voice, because it would have been trained earlier telling that if these are the words, this is the understanding you should have. So that is how the machine learning will work behind the screen of your Google voice search. And Google Photos. So here deep learning is also part of your machine learning. So deep learning uses lots of images like CNN and other things might many of you have used. And this Google Photos is also one of the example for your machine learning. So smart reply. So in the sense like you can make your students do simple applications like app based applications or email based applications, wherein in a smart way it should be able to give you an answer. So Google, how it does, like something is there, I'm not well means, or take care, something of that kind of a message automatically will pop up on your systems. So these are all few examples of smart reply that is adopted in the Gmail. But you can make your students work on this with the simple applications and try to use it for some good projects. And Google Maps, here also the routes would have been already trained, and dynamically we will be able to find out which is having a traffic route and which is not a non-traffic route, and Google automatically diverts you back to the non-traffic route. So these are all the applications of machine learning again. And having any image, you would be able to find out or detect the object seen and what are the activities that are going on. So how much is the percentage, so whatever the percentage that is showing, no, so that is actually the output of the machine learning, which is telling 99.3% he is a person. Okay, so like this you can do the activity detection, object detection, scene detection, you can know the scenario, all such applications you can develop. And facial recognitions, so this is a much important one, because nowadays all the students would be happy to take pics of their friend selfies and all that stuff. So ask them to do projects with the facial recognitions involving machine learning. And facial analysis is one more important thing, because here you can see smiling 100%, so she's happy. So 97.4% it is telling that she's happy. So depending on the pixels that we have within the face, we are able to make out whether the whatever the expression or the what is the particular um, uh, facial analysis that we can have, whether the eyes is open or is she sleepy. Because one of my scholar under me is working in automobile industry, and we are doing projects on this facial analysis for the driver monitoring. So like that you can just plan for few of the applications. Path recognition, so in the play what should be the next path, so that can also be used for the path recognition. Unsafe content detection, celebrity recognition, and even text in images. So if you have a lot of text along with the images, you can make out here. See, don't think outside the box. So don't is 98%, think is 99%. So what it is going behind the scene is, it is doing the natural language processing, trying to find out the text behind this particular image, trying to find out what those words are, and we are trying to predict whether it is this word or not. Like that you can do the text in images analysis. And text sentiment analysis, so you can have a positive write up or you can have a negative write up. So just by looking at the text we can analyze the sentiment behind the written statements. So we can predict how much positivity is there, how much negativity is there. So this is also lots of this also a lot of applications. And as I was telling you, recommendation engine, so if you have bought one purse or dress, based on that either a collaborative filtering would be applied or content filtering would be applied, which will give a recommendation of the products for you to buy your new products. So traffic prediction, so where the particular vehicles are, where the persons are, whether it is accident prone or without accident prone. So also traffic predictions also we can make using the machine learning. And online fraud detection, so here we will have a fraud score which will be evaluating whether the credit card that has been provided is the proper one or not. So we'll have the terminal check in the background, and if it is a fraud one it would be rejected, otherwise it would be accepted. So this is how one of the applications. And product search also is one of the applications. So as I told, any particular product you want to do, you can keep searching on the online. And self-driving car or autonomous vehicles, so here also you can see that without any intervention of external driver, we are able to drive our cars, and it is automatically driving your car, but it needs a proper lane and other things. um, so in India this has to be still more developed, so lots of research areas are there with respect to self-driving car or autonomous vehicles, as I was just now telling with respect to driver monitoring. And lots of gaming applications you can plan with respect to machine learning. You can give your students some small assignments which they can start working on and try to develop their own simple gaming applications, and then which can be collaborated together to form a big product or an application. And you can do the patenting of your products as well once it is having a novelty compared to the available ones. And virtual personal assistants, so Siri, Alexa, Google, Cortana, so how can I help you? So this kind of applications we have been seeing. And email spam and malware filtering, so whatever the mail that comes to your inbox, that has to be divided into either spam or non-spam, and this is also application of your machine learning only. So naive algorithms would be used here for this. So this is one of the project what we did, medical diagnosis of cervical cancer. So here we could found the tumor, whether it is present or not, and in what stage it is in. So like this, lots of medical diagnosis we can do with respect to cervical cancer. So as of now, I am working on many interdisciplinary projects in Ramaya University. So one project is on dental department. So we have a periodontics department in the dental, and they have the problem with the bone growths. And we are able to do the predictions using the ML models, because the problem that what they had was the doctors, once they prescribe the medicine, the patient won't turn back if the problem does not persist. and they doesn't know like how much bone growth has happened and how the medication is working. So we are working on that kind of problem statement provided by the periodontics department, and now we have got the results. So that's the reason here we are actually doing it for publication as well as patent as well. So one more project I can say, I'm doing it with the civil department. So civil department people, they wanted us to give a prediction using the ML models, like how much work has been done on a site, so excavation site especially. So when the excavation is happening, they wanted to know like how much work has been done in the on site. So how much bucket is full, how much machines have been utilized throughout the day, how many persons are working at what hours. So all those things the manager could be able to manage within his sitting place only. And this has been taken care by a few of the outside companies also. They have actually contacted us for our product. So like that you can do lots of projects. Even in one more project I can say is with the robotics department, and which is collaborated to the medical department as well. Like medical people in the dermatology department, they had to do the treatment for the skin, but the doctors were complaining that whatever the radiations that they were using for the treatment of that skin, so they were also affected, the doctors were also affected. So they wanted a robotic solution to it, which can be autonomously maintained. So for that also we are using this ML models. So like that you can plan your own research in your particular interest or your domain, and start working on it. So and I also tell that you have to tell your students to do such projects, so they would be more interested in doing all this stuff. So only thing is from your end guidance would be required, and they would do a lot of work. So finally, to conclude, machine learning is quickly growing field in the computer science, and it has almost all applications in each and every field of the study. So it's not pertaining to CSE only. Any interdisciplinary project that I'm trying to do now, so it is all interdisciplinary only. So even in the medical diagnostics also we are working few of the projects. So in general I just want to conclude that it is giving you better accurate predictions based on the patterns that you are going to observe. So please try and find out what research you want to do, search for the papers, do the research gap analysis, and start doing your objective, and also start working on the research projects. And thank you. Any questions from your end, you can come.
Any questions from audience? No, I think there are no questions from audience. Thank you very
Okay.
much for your very informative talk on machine learning. Though it was
Yeah.
in fundamentals of machine learning, you explained very detailed, and this description was very clear. I hope all the faculty members who are actually new to machine learning must have enjoyed and understood your talk. And in spite
Thank
of
you so
your
much.
ill health and health condition, you just made up your mind to share your thoughts on machine learning. Really, we are all grateful to you for that.
Thank you for the opportunity, sir.
Yeah, sure.
Yeah.